Hello students. In my last class, I have completed the chapter The Structure of the Earth with all its exercises and the question answers. Today, I am going to start the new lesson from your book, that is chapter number 3, Earth Movements and Major Landforms. Children, you know that landforms, what you see on the Earth's surface, it is not the same or it is not the same what it was initially, okay, and it is constantly changing. So you will be thinking that from the beginning there were 7 continents and 5 oceans, but the picture was not like this. Actually, the earth, about 250 million years ago, it was actually the continents were joined together as a supercontinent known as Pangea. Okay, so we'll read in this chapter, and we'll see how the major landforms came into being and how they are still changing and how the study is still going on. So there are lots to know about the earth. Okay, so there is lots to study about the different changes going on inside the earth's surface, as inside the earth as well as on the earth's surface. So okay, everyone follow the book, page number 108. Our earth has not always looked the same. About 250 million years ago, all the continents were joined together as a supercontinent known as Pangea. So the picture was not like what we see on the earth's surface. Now we see that there are 7 continents separated by 5 oceans, right? But before it was not like that. About 250 million years ago, the surface of the earth was not divided into 7 continents, but it was only one supercontinent, and that was Pangea. Okay, so there was only one supercontinent, Pangea, and a huge ocean, only one known ocean, that was Panthalassa. So Pangea and Panthalassa, Pangea is the supercontinent that existed about 250 million years ago, and Panthalassa was the huge ocean in which the Pangea existed. Okay, and according to the theory of continental drift put forward by a well-known geoscientist, Alfred Wegener, the supercontinent Pangea began to break up about 200 to 225 million years ago. So, long back in 200 and 225 million years ago, what happened? The Pangea, which was a supercontinent, started to break up, started to drift, and then they started to break up into 7 continents. And this is the continental drift. That is the theory of the continental drift, is the theory that the earth's continents moved over geological time and appearing to have drifted across the ocean bed. So it is actually the continents that have separated as the 7 continents. The supercontinent Pangea separating into the 7 continents, what we know or what we see today. Okay, so all the 7 continents that is now present is Africa, Antarctica, Asia, Australia, Europe, North America and South America. So these are the 7 continents present on the earth's surface, and the theory of continental drift proves that these continents, which was before together known as Pangea, supercontinent, that was previously referred to as supercontinent Pangea, that drifted, that separated into these 7 continents, is the theory of continental drift. Okay, and the 5 oceans also, that is the Arctic Ocean, the Southern or the Antarctic Ocean, the Indian Ocean, the Atlantic Ocean and the Pacific Ocean. And then there is division for Atlantic Ocean as North Atlantic Ocean and South Atlantic Ocean, and the Pacific Ocean is again there is division for it as North Pacific Ocean and South Pacific Ocean. Okay, so these are the oceans and the continents we see on the earth's surface today, but it was not so 250 million years ago. Okay, so it was a supercontinent as Pangea and a huge ocean Panthalassa. Okay, now the theory says that initially two massive continents, Laurasia and Gondwana land, were formed, eventually fragmenting further to form today's continents. So, as I said, it was a supercontinent for Pangea. Then Pangea was drifted as was like what to say that the Pangea again formed two massive continents, Laurasia and Gondwana land. Okay, so first there was a supercontinent Pangea, then it again broke or it formed two massive continents, that is Laurasia. Laurasia was the large northern continent, that is the upper part. Okay, the upper part, and the Gondwana land was the southern continent, that is the lower part. Okay, understood? Eventually fragmenting further to form today's continent. So from Pangea they formed two massive continents, that is Laurasia and Gondwana land, and then from Laurasia and Gondwana land again it fragmented to form these 7 continents what we see today. Now next topic, lithospheric plates. The Earth's crust is broken up into series of plates called lithospheric plates. There are 7 major lithospheric plates and some minor ones. So lithosphere, by the name itself you can make out that is the land part. Lithosphere means land part, and you already have read previously that 71% of the total area of the lithosphere is covered by water and 29% is occupied by land. So you already know that lithosphere is constituted with 71% of land, 71% of water and 29% of land. Okay, and here there are 7 major lithospheric plates and some minor. So here you come to know that there are 7 major lithospheric plates. Okay, and plates, what are plates? Plates are the plates we can define as which carry the continents and the ocean floor. Okay, plates we can define as plates are those which carry the continents, which has both the continents and the ocean floor. Okay, now, or you can say the blocks of landmass are also known as lithospheric plates. Okay, so actually plate may be referred to as the block of landmass. Okay, the block of landmass, as we know the maximum part of the lithosphere is covered by water, and so the blocks of landmass that is present there is also known as the lithospheric plates. Okay, now you can see the 7 major lithospheric plates, that are the African plate, the Indo-Australian plate, the Eurasian plate, the Pacific plate, the North American plate, the Southern American plate, and the Antarctic plate. So you remember these 7 plates, the 7 major lithospheric plates. Now we will read about the plate movement. The lithospheric plates are constantly in motion. So you know these plates, whatever or the land mass, the blocks of land mass what we see on the Earth's surface are constantly in motion. Why? You will think why they are constantly in motion. The tremendous heat generated inside the core of the Earth causes the rocks in the mantle to melt. These molten rocks expand, rise, and push the plates away from each other. Okay, so we know that there is always some activity going inside the surface of the Earth. Okay, so we have already read that about the different layers, okay, about the different layers in the structure of the Earth. So some of the other movement is going inside the Earth. Okay, so these movements, that is the heat and the whatever the movement is going on, or we already know that magma is present inside this Earth. So the layers, as we have already discussed, the core, mantle and the crust, and we know that there is liquid also liquid core also present inside the surface, and that produces heat and lot of pressure. Okay, so these tremendous heat generated inside the core of the earth causes the rocks in the mantle to melt. Because of the heats, the rocks in the mantle, they gets melted, and these molten rocks expand and push the plates away from each other. Because of the heat and pressure from inside the earth, these pushes the plates away from each other. Okay, whenever there is, if you know, there is heat and pressure, then automatically it will push it upwards, it will push, and this pushes away the plates. When they cool down, they sink and bring the plates towards each other. So when, even in the science also you have read that whenever there is heat and pressure, it puts pressure. Okay, whenever there is heat and pressure, then it will put pressure on some object, and when it cools down, then again the object comes back to its normal position. The same way happens with these plate movements, and when they cool down, they sink and bring the plates towards each other. This process is known as plate tectonics. Okay, this is plate tectonics. Plate tectonics is actually the that is the moving of the plates from each other because of the heat and pressure. And again, when the molten rocks expand, or when the heat and the pressure subsides, then what happens? They again sink back and they bring the plates towards each other. Okay, there are three types of plate movements: convergent plate movement, divergent plate movement, and transform plate movement. So there are three types of plate movements. This is convergent, divergent, and transform. Now, what is convergent plate movement? So convergent plate movement occurs when, due to forces of compression, two plates move towards each other and they collide. As you can see in the picture, in the convergent plate movement, what happens? Due to the forces of compression, the plates are moving towards each other. Okay, as they are moving towards each other, what happens? They collide. In convergent, you should always remember that the plates are moving towards each other, and if the two plates are of equal density, like if they have the same density, then what happens? They push up against each other. So when they are moving towards each other and they have the same density, then they will push up against each other, forming a mountain chain. Okay, but if they are unequal in density, if the density is not equal, then one plate sinks beneath the other. Okay, so one plate will slide below the other. So these are the convergent plate movement. Now, divergent plate movement. Divergent plate movement occurs when, due to forces of tension, two plates move away from each other. In convergent, we saw that the plates are moving towards each other, but in the divergent, we see that the plates are moving away from each other. And the divergent plate movements, what happens? Rifts, this within continents produce rifts. Okay, which becomes rift valleys, because as the plates are moving away from each other, they produce rifts, and these rifts are called rift valleys. Okay, when plates move apart from each other, they produce gaps or rifts, and where because the gaps are already present, what happens? The molten lava rises to fill that gap, and they take the shape of valleys. You can see in the picture also the divergent plate movement. Now, transform plate movement. The transform plate movement occurs when the two plates horizontally slide past each other. You can see in the picture that in the transform plate movement, what happens? These plates are moving horizontally past each other. One is moving in this direction and one is moving in the other direction. Okay, so these are the three plate movements that we come to know in this chapter. Okay, convergent moving towards each other, divergent moving away from each other, and transform is when the two plates horizontally slide past each other. So these are the 3 plate movements. You will study in detail further in your higher classes. So for the time being, you should only know about these 3 types of plate movements and what happens during these plate movements. Now we will move to earth movements. The movements of the earth are divided on the basis of the forces that cause them. The forces that acts inside the earth are called endogenic or internal forces. So we have already known or read about the internal forces. Okay, they are of 2 types: sudden forces and dystrophic forces. Sudden forces, we already know that sudden forces are earthquakes or volcanic eruptions and landslides which occurs suddenly. You will not get any idea then when it is going to happen. Okay, it occurs suddenly without any what you say warning. Okay, so it occurs suddenly. So these are called sudden forces. The like earthquakes and volcanic eruptions, you don't know when it is going to occur. Earthquakes and volcanic eruptions or landslides, you don't know when it will happen. So it occurs all of a sudden. So these are sudden forces. And dystrophic forces, mountain building. So and another force is that which helps in the formation of mountain, that is dystrophic forces. Okay, the forces that work on the surface of the earth are called exogenic or external forces, like river, glacier, wind and sea waves. They act slowly and result in erosional and depositional activity. Now we have already read about the forces of nature. We have already read in that you remember the sedimentary rocks. We have read that how the forces of nature like river, glacier, wind and sea waves cause erosion and then they deposit sediments and how they are transported with the help of river. You have remember all those, right? So these are also the forces that works on the surface of the earth and they are called external forces. Okay, these are external forces because you can see them. What are external means? You can see them. We can see the glacier, wind, wind we can't see, we can feel, but we know that the wind is blowing, and if it is in high pressure, we know that what the impact it has. Okay, so same way that river, glacier and waves also we can see that when it's striking on the surface of a rock or that is erosion is going on, that we can feel. Okay, so same way these are the external forces and they act slowly. It's not a very fast process. They will act slowly and slowly they take out or erode the layers, okay, as sediments. Now volcanoes. A volcano is an opening on the earth's crust through which magma comes out onto the earth's surface. So volcano, we already have an idea. In my last class also I had discussed the types of volcanoes. Okay, so actually during volcano what happens, the molten magma that is inside the earth that comes out onto the earth's surface in the form of lava. You know that the magma that reaches the earth's surface is called lava, and the passage through which it travels is called a vent. Okay, vent is the passage, means the molten magma needs the way to come out on the surface of the earth, and it travels through the vent, and in course of time when it comes out it becomes lava. In course of time, lava and other materials like ash and cinder thrown out of a volcano accumulate around the opening and form a conical hill or a mountain. You know that the magma is in the molten state, and when it is coming on the surface, it will come with a full force, right? So when it comes out in full force, then it forms a conical hill or a mountain. Okay. The top of the volcano has a cup-shaped or a funnel-shaped depression which is known as the crater. If you notice the picture of a volcano, you will see that the top of the volcano is cup-shaped. It becomes the shape of a cup and cup-shaped, or you can say funnel-shaped depression, and it is known as crater. Okay, that is the top part of the volcano which is in the cup shaped or funnel shaped, it is known as the crater. On the basis of frequency of eruption, volcanoes can be classified into three types. Already I have discussed this three types of volcanoes, that is the active volcano, dormant volcano and extinct volcano. So active volcano is the one in which continuous volcanic activity occurs and eruptions can take place anytime. So examples are given: Mauna Loa in Hawaii and Stromboli in Italy. Okay, so these are the active volcanoes. Active volcanoes, active by the word active only, you can make out active means which can have volcanic activity anytime and the eruption can take place anytime. Okay, so as we know, these are all the sudden forces, right? So volcanoes, when there will be volcanic eruption, no one knows, because these are all sudden activities. So active volcano also which are active or which can have the volcanic activity anytime. Dormant volcano is one which has not erupted for a long time but may erupt anytime. And examples are given: Mount Fusiyama in Japan and Mount Vesuvius in Italy. Okay, so dormant volcano, as I earlier also told you, that dormant means sleeping. Okay, sleeping volcanoes. Why we call sleeping was because maybe at one time it had erupted, but after that there is no activity in that volcano, and it has been maybe many years that it is not erupted, and so they are described as dormant or sleeping volcanoes, or because there are no chances that they may erupt anytime. Okay, extinct, no, but they may not erupt at any time, we expect that, but maybe there may be sudden activity in the dormant volcano. It's not like they have completely slept. Okay, these are dormant volcanoes. Actually, maybe there is long time they have not erupted, but there are chances, because as we are calling it sleeping volcanoes, there are chances that there can be eruptions. So that is called dormant. Dormant means they are sleeping, in the sleeping position. So there are chances that at one time there may be eruptions. Okay. An extinct volcano is the one that has no record of eruption and no possibility of eruption in future. For example, Mount Kilimanjaro and Mount Kenya in Africa. So these are extinct volcanoes, are the volcanoes actually that are said that one time they had erupted, but there are chances that they may not erupt again anytime. So there are chances that there will be no eruptions in the volcano. So these are the three types of volcanoes: active, which are active, which can erupt anytime; dormant means sleeping volcanoes, which have not erupted for a long time but there are chances that they can erupt anytime; and extinct volcano that has no record of eruption for a long time, and even there are no possibilities, means there are no chances that they will erupt again, okay, in the future. So most of the active volcanoes of the world are located in a circular belt area around the Pacific Ocean known as the Pacific Ring of Fire. Some volcanoes are also found in the Mediterranean Sea and the Caspian Sea known as the Mid-World Mountain Belt. You can see here in page 110, you can see the earthquake belt of the world. Here you can see the earthquake positions. Okay, these are the earthquake positions in the different places of the world. So you go through this map. In the next class we will discuss about the earthquakes. Okay, earthquakes and how it is so dangerous and what effect it has. So we'll go through this earthquake part in my next class. Till then you read till here, and you also read the earthquake part also, so you will have a better understanding when I teach you in my next class. Okay, so children, I will stop my class here. Have a nice day. Thank you.